This is lesson 11.3, conditional probability. The objectives for today's lesson are to be able to define conditional probability and construct and use a two-way table to find the conditional probability of an event. All right, so what is conditional probability? So it's the probability that an event will occur based on a condition that another event has already occurred. So conditional, right? So example, the probability of a person owning a dog given that the person also owns a cat. So the way you can tell that you have a conditional probability problem is you'll see this word given, right? Or you might see the word if, the probability of a person owning a dog if the person also owns a cat. So you'll see like this given that, or you'll see if, right? So that's how you know you have a conditional probability problem. Okay, so the way that we calculate conditional probability, right, is we calculate the probability of A and B occurring and divide it by the probability of A. So we read this as B given A, right? So B given A, this is sometimes called a such that bar, so B such that A, okay? And this is just how we write this. So I suggest that you write this formula right here down on your paper. Okay, so probability of B given A, we do the probability of both happening over the probability of just A happening. All right, so the reason why this is this way, so the probability of B given A, so like the probability of owning a dog if you already own a cat, right? So we're looking at if you own a dog, if you already own a cat. And so that's why owning a cat right here would be your total, right? So they have to own a cat. We're looking for the probability of owning a dog if you already own a cat. So our total is owning a cat. And then we're going to count up how many people own both a dog and a cat. Okay, make sense? All right, so let's try it. Rolling a pair of dice. Once again, we need our lovely sample space for a dice. I hope that you wrote it down. Okay, so have a nice little sample space for dice on a card somewhere that you can use on all of these and on the test. I mean, I don't know. It's not bad to write it every time. It's just kind of a pain. Okay. All right, what is the probability that both numbers are odd if their sum is 8? Okay, so we're going to do the probability that we have both odd and sum of 8 over the probability of sum of 8. Okay. All right, so let's try this. So I'm going to do probability of odd in blue. Okay, so I'll do odd in blue. All right, so both numbers odd. So that's 1, 1, 1, 3, 1, 5, 3, 1, 3, 3, 3, 5, right? Okay, so that's both numbers are odd. Let's do sum of 8 in red. Okay, so what adds to 8? So 1 plus nothing, you can't make 8. 2 plus 6 is 8. 3 plus 5 is 8. 4 plus 4 is 8. 5 plus 3 is 8. 6 plus 2 is 8. Okay. All right, so probability of odd and 8. So how many were circled with both blue and red? So there's just 2 of them. And then the probability of 8, how many circled were in red? So 1, 2, 3, 4, 5. So 2/5. Okay, so that makes sense. So you have to find the probability of both things happening and then put it out of the probability of your condition, right? So if the sum is 8, that's the condition. All right. Here I've put a sample space. I got tired of writing them. So what is the probability that the sum of numbers is 7 if both numbers are odd? So we need the probability of sum and odd over probability of odd. Okay? All right, so let's try this. So I'll do probability, the sum is 7 in red. So 1 plus 6 is 7, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, 6 plus 1. So there's all our 7. Now let's do odd in blue. So odd in blue, both odd. So 1, 1, 1, 3, 1, 5. And then 3, 1, 3, 3, 3, 5. 5, 1, 5, 3, 5, 5. All right, so both numbers odd. Okay, so here's something interesting. How many are circled in both blue and red? 0. Okay, and then the probability that both are odd, that was our blue. There are 9 of those. So this has a 0% chance of happening. Okay, nice. All right, next one. The buses at the Zumi Express Bus Company depart as scheduled 80% of the time. The buses depart and arrive as scheduled 68% of the time. What is the probability that a Zumi bus arrives as scheduled if it departs as scheduled? So this time we're going to use our little formula. So arrives as scheduled and departs as scheduled. If it departs as scheduled, right? So depart, right? So the thing that goes on the bottom is always what you have after the words if or after the words given. So you look for what comes after it or given, and that's what's going to be on the bottom of your fraction, right? That's how you tell. Okay, and this is the probability of A given D, okay? So what they've done here is they said it departs 80% of the time. So we're going to change these to decimals. 80% is the decimal right here. So departs 80% of the time. That goes on the bottom. All right. Now the next thing that they've given us is they depart and arrive as scheduled 68% of the time. So they've given us depart and arrive. And we're trying to figure out what's the probability that it arrives as scheduled if it departs as scheduled. So we're trying to solve for this. So we just need to type this fraction here in our calculator and get the answer. All right. So they've given us 80% is the depart. They've given us 68% is the and, right? And so we've plugged those in and we're going to type it in. So 0.68 divided by 0.80, and I get 0.85. And so we change that to a percent, 85%, right? In the problem, they've given you percents. So we're going to write our answer in percents. It's kind of like the rule of math. If they give you fractions in the problem, answer is fraction. If they give you decimals, answer in decimals. If they give you percents, answer in percents, right? Keep the units the same. Okay, conditional probability can also be determined using two-way frequency tables. We'll show you what one looks like in a second. And if you're given an incomplete table, find all the missing values first. All right, so let's fill out this table. So you can see, whoops, we call it a two-way table because it shows two different pieces of information, right? You have grade going this way, 10th, 11th, or 12th, and you have place of employment here, right? Taco Bell, Purple Turtle, Domino's, right? So two-way table because you have two pieces of information going a different way. All right. So, and then we also have totals. The totals are really important. If you ever have a table that doesn't have the totals, you'll want to fill those in. Okay, so let's fill this in. So all we have to do is look for places where we have like 3 of the 4 information. So like right here, right? So for Taco Bell, we have 1 10th grader, 11 12th graders, and 14 total. So we know that we need 14 total here. So 11 plus 1 is 12. Which means there's 2 more to get up to a 14 total. Okay. All right, so now let's look somewhere else. So I have the 2, whoops, if I look at 11th graders, I have 2, 1, 5, I just need the total, right? So you can add that up. 5, 6, 7, 8. So there we go. Look for another one where we have most of the data, right? So I have most of the data for right here, my totals, right? So I have 14, 9. I'm missing enough for 34. So if we add those up, there's 11 missing right here. Okay, and now I have almost all the pieces going this way, right? So 5 plus 4 is 9, so there's 2 here for dominoes. Okay. Now I'm only missing purple turtle for the 10th graders, but I know there's 8 total, so 2 plus 1 is 3, which means 5. Okay, it's kind of like a Sudoku puzzle, right? All right, and then last piece of data right here, I need purple turtle for 12th graders. Okay, so I know I have 9 total. 5 plus 1 is 6, so 3. Okay, now you can double check your work. It's always a good idea to double check that all your totals actually work, right? 1 plus 2 plus 11 is 14, right? Add up and make sure all your totals actually work going both directions. 1 plus 5 plus 2 is 8, etc. Right? So make sure that all your totals work and you didn't make a mistake somewhere. All right. So now here's the same chart, and we're going to use this to find out what is the probability that a student is in 10th grade if they work at Domino's. So remember our conditional probability formula. Probability that a student is in 10th grade if they work at Domino's. So we have to do 10th grade and Domino's out of probability of Domino's. So 10th grade and Domino's, where do we find that? So 10th grade and Domino's, that's right here, it's 2. All right, and then probability of dominoes total, there are 11 total dominoes, so 2 out of 11. Okay, so it's not too bad. Let's look at B. What's the probability that a student works at Taco Bell if they're in 11th grade? So probability of Taco Bell if they're in 11th grade. So we need probability of Taco Bell and 11th grade over probability of 11th grade. So let's look at Taco Bell and 11th grade, that's 2. And then probability of 11th grade, so we need to go here to the total for 11th grade is 8, and that will reduce to 1/4. Okay. Next one, probability that a student is in 11th grade if they work at Taco Bell. So this time we're kind of doing it backwards. 11th grade if they work at Taco Bell. So 11th grade and Taco Bell over probability of Taco Bell. So 11th and Taco Bell is 2. And then total Taco Bell is 14. Okay. All right, last one. We want to talk about fairness in a game. So Barbie and Ken are playing a game where they draw cards from a standard deck of 52 cards. Barbie wins if she draws a face card. Ken wins if he draws a black card. Is the game fair? If not, who has a better chance of winning? So let's see. Barbie wins if she draws a face card. So how many face cards are there? So the face cards are Jack, Queen, and King. And there's 4 of each of them in a deck. So you've got 12 total face cards, 12 out of 52 probability for Barbie. So what about Ken? Ken wins if he draws a black card. Well, half the cards in a deck are a black card, right? So 52 divided by 2, because half your cards are black. All right, so that's 26. So Ken has 26 out of 52 chance of winning. So you can see here, is the game fair? Definitely not, right? Ken has a much bigger chance. He has 26 out of 52. Barbie only has 12 out of 52. Okay? So Ken has a better chance. All right. right, guys, that is it. That's your last lesson for the whole school year, okay? And it's been really sad to have to teach you this way. I hope that you'll stop by and say hi to me next school year when we get to go back to class and say goodbye. And I really enjoyed being your teacher this year, you guys. So thanks, good luck on your last test, and I'll see you next year.